Hi students, good afternoon to everyone. We were going through the relations, functions topic of our 11th class syllabus. I'm going through the reduced syllabus pattern and we can continue our topic of relations and functions. Okay, so tell me everyone, are you following the classes and are you understanding the concepts? So here understanding the concepts and what understanding the logics are going to be very important. My dear students, please quickly give me the replies. Are you following the classes? Are you understanding the concepts? So yesterday we were studying about Cartesian products and we have seen some 3 or 4 important note, and we also solved 2 examples, and next we have gone through the relations topic, and now we have to continue with our exercise problems. Now it is very essential for me to continue with our exercise problems because this exercise problems are going to be very important. Okay, so in this exercise we are going to study how to solve the problems on relations. How to solve the problems on relations. So good afternoon to everyone. Let us start our class. So tell all your friends to join the class as much as early possible, because so many of them are not attending the class. If they not attend the class, it is going to have a very bad impact for your 12th class syllabus. So that's why I am telling, please attend the class. Okay, now let us go through our problem, that is problem 1. See the problem 1, what they have given. What they have given here, let A be the set. So set A has 14 elements. Define a relation R from A to A. That means the relation is defined from set A to set A by R equal to set of order pair x comma y such that 3x minus y equal to 0. Such that 3x minus y equal to 0 where x comma y belongs to A. Where x comma y belongs to A. Write down its domain, codomain and range. Write down its domain, codomain and range. Okay. So they have given the set with the 14 elements. Define a relation R from A to A given by R is equal to set of x comma y such that 3x minus y equal to 0 where x comma y belongs to A, and we have to write its domain, codomain and range. Okay. So see my dear students, here first you must understand what is domain and what is range. So first you see here, domain of the relation. Domain of the relation is, the domain of the relation is collection of first element, collection of first element from the order pairs, from the order pairs of the relation, okay, from the order pairs of the relation. So this is called domain. Next you see what is codomain. Codomain means codomain of the relation is, codomain of the relation is collection of the collection of second elements, collection of second elements from the order pairs, from the order pairs of the relation, of the relation is called codomain. Clear? That means here you can understand. I will take one example, from that you can understand. See, if I write R is equal to 1, 1, 2, 2, 3, 3, 4, 4, 4, 3, 4, 2. Okay. So I will take, this is my relation on the set A equal to 1, 2, 3, 4 and 5. Now if I collect the first elements, that is 1, 2, 3, 4, that is going to be domain. So domain is going to be set of 1, 2, 3, 4. Okay. Now if you want to go for the codomain, codomain is going to be equal to collection of second elements 1, and here you have 2, here you have 3, and here you have 4. Okay. Here 3 is repeated again, so don't write the repeated elements. 2 is repeated again, don't write the repeated elements. Okay. So the domain is collection of first elements of the order pairs. Collection of first elements of the order pairs. Codomain is collection of second elements from the order pairs, is called codomain. Okay. So this is the domain and codomain. So from this, I think now you got an idea of what is domain and codomain and how to write the set of domain and codomain. So good afternoon to everyone. Good afternoon, AB, Chaitra, Radha, Rupa and everyone. Okay. So all names I can't take because there are more than 20 members. So good afternoon to everyone and welcome to the class. So tell all to attend the class. Some of your friends are not attending the class, so tell them these classes are very, very important. Okay. So then I think you have understood this about domain and codomain. Domain and codomain. Okay. So now let us go for the problem. Let us go for the problem. First you understand the problem and then you can write. Here relation is given in the form of order pairs x comma y such that 3x minus y equal to 0. This is in the form of set builder. This is in the form of set builder. Okay. So this is called set builder form. Already you know about set builder form and roster form. Set builder form means the set is given in the form of definition. Roster form means you have to collect all the elements. That means you have to do the list of the elements. Now the relation is defined and it is given in the form of set builder. So to write domain, codomain and range, we have to convert it for roster form. We have to convert it for roster form. And it is defined on the set A 1, 2, 3, 4, so on to 14. Okay. So now I have to write elements in the relation. So which type of order pairs are going to come in this relation? Who are going to satisfy this particular equation? Okay. So see here, if I take x value as 1, what will be the value of y? So here I have written x value as 1. Okay. What will be y? You just see. 3 into 1 is 3. Again, if I put which term to the y, it will be 0. I know that 3 minus 3 is 0. So if I put x value as 1, 3 into 1 is 3. Minus 3 will be equal to 0. Therefore, 1, 3 is the first order pair. 1, 3 is the first order pair. See the second order pair. If I write x value as 2, if I write x value as 2, now what you are going to write for y? 3 into 2 is 6. So 6 minus 6 is going to be equal to 0. Therefore, 2, 6 will be the second order pair. See the third order pair. If I write x value as 3, 3 into 3 is 9. So y value is going to be 9, because if I write y value as 9, 9 minus 9 is going to be equal to 0. Put x value as 4. 3 into 4 is what? 12. So 12 minus 12 will be 0. So therefore 4 comma 12 will be the second order pair. You see the next order pair, 3 into 5. It will be 15. That means y value I has to write 15. But 15 is not present in your set A. So that's why I can't write that element. So only I can write 4 comma 12. I can't go for 5 comma 15 because see, this 15 not belongs to set A. So that's why I can't write 5 comma 15. Are you clear? So have you understood this, how to write the order pairs? Now we have written this order pairs in the form of roster. So this is called roster form. This is called roster form. Okay. So now you write domain. What is the domain? Collection of first elements from the order pairs. So it will be 1, 2, 3, 4. Okay. Next, codomain. What will be the codomain? Okay. So here you can just see codomain and range are going to be the same elements. Okay, codomain and the range are going to be same elements here. Otherwise you can write codomain as A, that is set A, codomain as set A, and range will be equal to set of 3, 6, 9, 12. That means collection of the second elements. Collection of the second elements. That will be 3, 6, 9 and 12. So they have given codomain and range. So that's why here if range is asked, range will be the second elements. The range will be the second elements. Codomain will become your set A. Codomain will become your set A, and the collection of second elements is going to be range. So please correct it. Here they have asked codomain and range. That means they are differencing, but they are having the difference between codomain and range. Because of that, the collection of the second elements we shall put it in range, and codomain we call it as A. Codomain we call it as A. Okay. So all of you correct your answers. Codomain is set A and the range is 3, 6, 9 and 12. Okay. Suppose if they give only domain and codomain, you can write it as 1, 2, 3, 4 for domain. For the codomain 3, 6, 9, 12. But here they have asked range also. Here they have asked range also. If they asked the range, then you just replace the second elements 3, 6, 9 and 12 as the range. 3, 6, 9 and 12 as the range. Okay. So all of you quickly tell me, have you understood this? All of you quickly tell me, have you understood this? I will go for the second one. So see here, they have asked domain and range. No problem. They have asked only two sets, that is domain and range. Already you know, we can write the domain and range, no problem. Okay. So first you understand the problem very carefully. Define a relation R on the set N. Define a relation R on the set N of natural numbers. That means relation is defined on the set of natural numbers. Okay. R is equal to set of x comma y such that y is equal to x plus 5, comma x is a natural number less than 4. X is a natural number less than 4. X comma y belongs to N. Depict this relationship using roster form. Already you know what is roster form. Write down domain and range. Okay, no problem. Let us write domain and range. Okay. So no problem. You just see how to write the relation. First you write set. It is defined on natural numbers. Okay, no problem. Now what is R? R is equal to order pair x comma y such that y is equal to x plus 5, comma, x is natural number, x is natural number, x is natural number less than 4, less than 4. That is x comma y belongs to n. That is x comma y belongs to n. Okay. Next, now I have to write it in roster form. How to write it in roster form? You just see here. X comma y such that y equal to x plus 5, and this x is what? X is natural number less than 4. Okay. So that means I can take x value as 1. So if I write x value as 1, what will be y value? 1 plus 5. That is 6. Okay. Next, I can write x value as 2. 2 plus 5. That will be 7. That means y value will be 7. If I take 3, 3 plus 5, that will be 8. Okay. So now I can't write 4 because x value must be natural number and it should be less than 4. So that's why I can't take x value as 4. So we have to end this here. Are you getting my point? So 1 comma 6, 2 comma 7, 3 comma 8 are the elements which are present in R. Now you see about domain. What is the domain? That is equal to set of 1, 2, 3. And see codomain. What is codomain? You just see codomain is going to be equal to 6, 7, 8. Are you clear? Sorry, here they have said it as range. So let us write it as range. No problem. They have said it as range. So let us take it as range. Take it as range. Okay. So range is equal to 6, 7 and 8. And domain is equal to 1, 2 and 3. So quickly tell me all of you, are you following this? Very simple problems. Very simple problems. And here what is important that you understand. The important step is writing the relation from set builder form to roster form. Writing the set from set builder to roster form. So once you get practice of writing the sets from set builder to roster form, these problems are going to be very, very simple. So my dear students, here the very important logic is to writing the roster form to set builder form. Roster form to set builder form. Okay. So now let us go for third problem. So in the third problem, you can see what they have given. Okay. See here. Set A is 1, 2, 3 and 5. Set A is 1, 2, 3 and 5. Set B is 4, 6, 9. Define a relation R from A to B by R equal to x comma y. The difference between x and y is odd. The difference between x and y is odd such that x belongs to A, y belongs to B. Write R in roster form. Very good. So see how to write here. Please follow the logics what I apply. You see how I solve. I will write first 1, 2, 3, 5. Next I will write B equal to 4, 6, 9. Now what I has to do? I has to write R. What is R? R is equal to set of order pairs x comma y such that the difference between x and y the difference between x and y is odd. That is x belongs to A, comma y belongs to B. No problem. So this R I has to write it in roster form. So first let us take order pairs. First let us take order pairs. First x belongs to A. So from A I will choose 1. Okay. I will choose A as 1. What I has to choose? Y. Y is from B. See, first element is B. I can write 1 comma 4. Why do you know? Because 1 minus 4 is minus 3. This is odd. No problem. I can write this. Next you just see. 1 comma 6 I can write because 1 minus 6 is minus 5. Okay. Next you see. I can't write 1 comma 9 because 1 comma 9 is 1 minus 9 is minus 8, which is even. Okay. So I can't write 1 comma 9. Now I will go for 2. I can't write 2 comma 4 because 2 minus 4 is minus 2, that is even. So that's why I can't write that. 2 comma 6 also I can't write because 2 minus 6 is minus 4. 2 comma 9 I can write, no problem, because minus 7 you are going to get. Next I will go for 3. 3 comma 4 I can write because 3 minus 4 is minus 1. Next I can write 3 comma 6 because 3 comma 6 means 3 minus 6 is 3. No problem. I can't write 3 comma 9 because 3 minus 9 is minus 6, which is even. So I will go for 5. 5 comma 4 I can write because 5 minus 4 is 1. 5 comma 6 I can write because it will be minus 1. 5 comma 9 I can't write because it will be minus 4. So now you just see domain. Domain is going to be equal to 1, 2, 3, 5. Range is going to be equal to 4, 6, 9, 4, 6, 9 over. Okay. So domain is 1, 2, 3, 5. Range is 4, 6, 9. So therefore we can write these elements. Clear? So domain is 1, 2, 3, 5. Range is 4, 6, 9. Okay. So anyways, they have not asked for domain and range. No problem. They have only asked for writing it in roster form. So in the roster form, this much of order pairs you must get. So first you think, have you understood this problem to writing in the roster form? First you quickly tell me, have you understood to write it in the roster form? Okay. If you have understood to write it in a roster form, then it is very good. Okay. See this. Very important concept. Very important concept, and it has very big impact in solving so many type of CET problems, JEE mains problems, as well as your second year problems. Such important problem, that is question number 4. If this basics you know, then you can enjoy your most of the questions of JEE mains as well as Karnataka CET questions, because it develops some important shortcuts. So that's why I am telling, understand this problem very carefully. What they tell, the figure 2.7 shows a relationship. A figure 2.7 shows a relationship between the sets P and Q. Okay, no problem. That means there is a relationship between P and Q. Write this relation in set builder form and roster form. What is its domain and range? Okay, students. So first you see, what is this diagram? This diagram is called the geometrical representation of your relation. This diagram is called the geometrical representation of your relation, and it is also called as arrow diagram. Okay. is also called as arrow diagram, because it is very important to understand for your most number of the CET problems. You first understand it. What happens if I take any relation like 1, 2, 2, 3, 3, 4? What happens if I want to write arrow diagram? It will have two sets. The first set will be A, the second set will be B. In the first set, you should write the first elements, that is 1, 2, 3. In the second set, you should write the second elements, that is 2, 3, 4. So 1 goes to 2, 1 goes to 2, 2 goes to 3, 2 goes to 3, 3 goes to 4, 3 goes to 4. Okay. So this type of diagram is called as arrow diagram. So that's why we have to be very careful regarding this. Clear? Okay. So now you just see, first we should write this relation from P to Q in the form of set builder form. In the form of set builder form. So I will write P comma Q, small p and q, or you can write x comma y, no problem. Let us take only x comma y. So let us take x comma y. And the two sets are, first we shall write the two sets. Before I write the relation, let us write two sets. What are the two sets? P and Q. So P equal to set of 5, 6, 7. Q is equal to set of 3, 4, 5. Okay. So now you just see here, I has to write the relation R. Order pair x comma y such that, order pair x comma y such that y is equal to x minus 2. Y is equal to x minus 2, comma, x belongs to capital P and y belongs to capital Q. Y belongs to capital Q. Okay. Clear? So now you can just see, this will be in the roster form, because see here, if I write R, y is equal to x minus 2, I has to write the x element. First I has to write the x element, that is from P. So I will take 5. 5 minus 2 is what? 3. No problem. 3 is present in Q. No problem. Next element. Here you can take 5 minus 4. Sorry, you can take 6. What it will be? If I take 6 minus 2, it will be 4. So no problem. 6 comma 4. Okay. Next, you can take what? 7. So 7 minus 2, that will be 5. This is the answer. Okay. So now this will be your answer for your roster form. For your roster form. So this techniques you have to understand. This techniques, if you have understand, then it will be very simple. Okay. So you just see, if I take any another element, it will be not in this form. For example, you can take 6 minus 2. 6 minus 2 you can't write. If you write 6 minus 3, it will be 3. Okay, but 3 is not valid number for us. Clear? It has to satisfy this equation. See here, if I take first 5, 5 minus 2 is 3. If I take 6, 6 minus 2 is 4. If I take 7, 7 minus 2 is 5. So this is your required roster form. Clear? This is your set builder form. We have written it from this diagram, because you can just see that each and every element of Q are difference with 2. 5 and 3 has difference 2. 6 and 4 has difference 2. 7 and 5 has difference 2. Clear? So that's why we can write like this. Therefore, domain is equal to set of 5, 6, 7. Range is a set of 3, 4, 5. Range is a set of 3, 4, 5. So quickly everyone, give me thumbs if you have understood. Give me the thumbs if you have understood. Okay. Clear? So everyone can understand this very simple problem. By looking at that arrow diagram, you have to write it in roster form and set builder form. So in the arrow diagram, you can just see here. In the arrow diagram, you can just see here 5 maps to 3. So that difference between 5 and 3 is 2. 6 maps to 4. Difference between these two is 2. 7 maps to 5. The difference between this is also 2. So I can use that. I can use that logic. Okay. So very good. Like this, you have to understand the problems. Then you have to go for the next problem. Clear? So now let us go for the fifth problem. Now let us go for the fifth problem. Okay. What is the fifth problem? First you understand it. There is a set A with 1, 2, 3, 4, 6. Let R be the relation. Let R be the relation on A defined by A comma B, such that A comma B belongs to capital A. B is exactly divisible by A. B is exactly divisible by A. Okay, no problem. So here you just see this. Your first question is write it in roster form. Second question is write its domain. Second question is write its range. Okay, no problem. Let us write. So see this. For the first problem, write it in roster form. What is A? A is 1, 2, 3, 4, 6. What is R? R is equal to order pair A comma B such that A comma B belongs to A. B is exactly divisible by A. B is exactly divisible by A. No problem. So first you see the R. What should I write? B is exactly divisible by A. So both A and B belongs to set A. Both A and B are in set A. So first, no problem. I will write the B element. That is 1. First I will write 1. Why? Because both A and B belongs to set A. So that's why first I will write B element. That is 1. So see this, I will write it as 1. So now B is exactly divisible by A means 1 is exactly divisible by what? You have to see. So 1 is exactly divisible by which element? 1 is exactly divisible by 1. Okay, that means 1 by 1. 1 is exactly divisible by 1. That will be the answer as 1. So now see. So another elements. 1 is not divisible by 2 because answer is 0.5. These types of elements are not allowed because exactly divisible means remainder must be 0. Exactly divisible means remainder must be 0. So here decimals are not allowed. Decimals are not allowed. Okay. So that's why I can't write 1 by 2. Please understand this. If I write 1 by 2 decimals, it will be 0.4. That is not allowed. That is not allowed. Okay. So 1 comma 1 will be the first element. See the second element. I will write 2. Now 2 is exactly divisible by 1 because answer will be 2. Okay. So 2 is exactly divisible by 1. On the same way, 2 is exactly divisible by 2 itself. 2 is exactly divisible by 2 itself. No problem. Now other than 2 is not divisible by 3, 2 is not divisible by 4, 2 is not divisible by 6. Now I will go for 3. 3 is exactly divisible by 1. 3 is exactly divisible by 3. Other elements are not going to divide it. Next, 4 is exactly divisible by 1. 4 is exactly divisible by 2. So other elements can't divide it. 6 is exactly divisible by 1. Another element is 6 is exactly divisible by 2. 6 is exactly divisible by 3. On the same way, you see here 4 is exactly divisible by 4. Okay. And also 6 is exactly divisible by 6. So these are going to be the order pairs. See, 1 is exactly divisible by 1. 2 is exactly divisible by 1. 2 is exactly divisible by 2. 3 is exactly divisible by 1. 3 is exactly divisible by 3. 4 is exactly divisible by 1. 4 is exactly divisible by 2. 4 is exactly divisible by 4. 6 is exactly divisible by 1. 6 is exactly divisible by 2. 6 is exactly divisible by 3. And 6 is exactly divisible by 6. Okay. So therefore, this is going to be your order pairs. Clear? That means if you want to write in the order pair, the B element, if I take 6, it has to be exactly divisible by the first element. I know that 6 is divisible by 1. 6 is divisible by 2. 6 is divisible by 3. No other elements divides it. So that's why 1, 6, 2, 6, 3, 6. On the same way, you take 4. 4 is exactly divisible by 1. On the next, 4 is exactly divisible by 2. Next, 4 is exactly divisible by 4. Okay. So this is your answer. So quickly tell me how many of you have understood this? How many of you have understood this? Quickly tell me. Because you have to understand this type of problems. Then only you can understand the further things. So quickly tell me how many of you have understood this. Now range and domain you can write easily. I know that. Range and domain you can easily write. Range is going to be equal to 1, 2, 3, 4, 6. The range is 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. And domain is also 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. Okay. So what about Yuvraj and Sneha? Have you understood this? Both of you? Yuvraj and Sneha, please reply me quickly. Both of you, have you understood this? See here, they are asking to write the order pairs A comma B. They are asking to write the order pairs A comma B such that A comma B both are in set A. A and B both are in set A. That means the first element and the second element has to be chosen from set A. The second element is exactly divisible by the first element. Clear? So like that, you have to collect the order pairs. For example, if I take this as 6, you see here 6 is divisible by 1, 6 is divisible by 2, 6 is divisible by 3. So 1, 6, 2, 6, 3, 6. Like that you have to do for all the elements. 6, 4, 3, 2, 1. Okay. That's what the logic you have to apply for the question number 5. Now let us go for question number 6. So sometimes unfortunately I will lose the connection between internet and my laptop because of the power cut. So if happens like that, you understand that because of power cut, the connection has gone, and you can just close your YouTube and you can go through your works. Clear? Because I will also not knowing that when the current or the power will go. So unfortunately, if it goes, if the connection get lost, then no problem. You have to understand that because of power cut, the connection has been gone. Okay, and you can just close the video and you can go for your works, no problem. But if the connection not goes until I end the class, no problem. I will tell I am going to end the class. If I end it, no problem. Before I end the class, if you lose the connections, it is the problem of power cut. Okay, so keep in your mind. Because of that, in 2 or 3 classes, I have got some confusions between students and internet connections. So that's why I'm explaining now only, so you understand that. Okay, now let us go for the 6th problem. You just see what is the 6th problem. Determine the domain and range of the relation R defined by R is equal to set of x comma x plus 5, x comma x plus 5 such that x comma x plus 5 such that x belongs to set of 0, 1, 2, 3, 4, 5. They have given everything in R, no problem. Now R is equal to, I has to take x from this. So this will be, if I take 0. So if I take 0, x value as 0. So 0 plus 5 will be 5. Next, if I take 1, x as 1. X as 1, 1 plus 5, that is 6. Okay. Next you see, if I take x value as 2, 2 plus 5, that is 7. If I take x value as 3, 3 plus 5, that is 8. Next, if I take x value as 4, 4 plus 5, that is 9. If I take x value as 5, 5 plus 5, that is 10. So this is your relation. This is your relation. Okay. So therefore here you can see domain is equal to set of 0, 1, 2, 3, 4, 5. And range you have 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. Okay. So this is the domain and range of your given problem number 6. So very good. So many of you are replying with the correct answers. Very fine. That means the concepts are clarified to everyone. The concepts are clear to everyone. Okay. These are the very simple concepts with very wonderful logics behind them. So once you understand them, then it is going to be very interesting to solve the problem. But please see, if you don't understand the logics, these things are going to be really very horrible. These things are going to be really very horrible. So that's what I say. First you understand the logics. Then you can go through it. Clear? So that's why I am telling, first you please understand the logics behind the problem. Then you can go on solving them. Clear? So that thing will be very easy. Clear? Okay. So that's why what I say is, first you understand the logics behind the problem, then you can enjoy those things. Okay. Now let us go for the 7th problem. Say this. Write the relation R is equal to order pair x comma x cube such that x is a prime. X is a prime number less than 10. X is a prime number less than 10. Okay. So if you understand the logic, it is very good. If you not understand the logic, it is very horrible. Okay, first see, X is prime number less than 10. That means I can take 2. So 2 is prime, no problem. What is 2 cube? 2 cube is 8. Next, 3 is prime number. I can write it here. What is 3 cube? That is 27. I can write it here. So next 4 I can't write because 4 is not prime. I can write 5. 5 is prime number. 5 cube is what? 125. I can't write 6 because 6 is not prime. I can write 7. But here you have to write 7 cube. So what is 7 cube? 343. 8 I can't write. It is not prime. 9 I can't write. It is not prime. Therefore, this is your answer. Okay. For your problem number 7. For your problem number 7. Clear to everyone? Okay. So now they have not asked domain and range. No problem. Let us go for problem number 8. That is A equal to X, Y, Z. B equal to 1, 2. Find the number of relations from A to B. So already you know n of A has 3 elements, n of B has 2 elements. So now the number of relations are 2 to the power of n of A into n of B. Therefore 2 to the power of 3 into 2, that is 2 to the power of 6, that is 64 relations. So totally you can define 64 relations from set A to set B. You can go for 64 relations from set A to set B. Clear? Very good. So most of you got the right answer. Very fine. That means the problems are clear to everyone. The problems are clear to everyone. Ninth one. You just see the ninth problem. Let R be the relation on Z. R is equal to set of order pairs A comma B such that A comma B belongs to Z. A minus B is an integer. A minus B is an integer. Write, find domain and range of R. Find domain and range of R. Okay, students. So see here. This is really very interesting problem that you have to understand. See, A comma B belongs to integer set. That means Z is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3, so on. This is infinite set. This is infinite set. Okay. So here you can just see, if I go on writing the R, that is A comma B. For example, I will start with 0. I can write 0 comma 0 because 0 minus 0 is again, see here, 0 minus 0 is again 0, therefore it is integer. I can write 0 comma 1 because you just see 0 minus 1 is what? See, 0 minus 1 is what? Minus 1. Again it is integer. I can write 0 comma 2. I can write 0 comma 3. Like this, it goes on. It goes on like this. It never stops because see here, 0 minus 3 is again minus 3. You can write it as 1 comma 0 also because 1 minus 0 is 1. You can write it as 1 comma 1 also. You can write it as 1 comma 2 also. Again you see here it goes on like this. Okay. That means here you just see R is infinite relation. R is infinite relation because you can just see that all the order pairs are not going to end. Okay. Now from this you can say domain. Domain will be what? Complete your Z. That means integer set. That means integer set. Range. is also again same. Z, that is again integer set. That is again integer set. Okay. So domain and range both are going to be your integer set. Both are infinite. Both are infinite. Okay. So that's why, because this relation is infinite set, that means infinite relation, you can just see, you can go on writing like this: 0, 0, 0, 1, 0, 2, 0, 3, so on. You can also write 1, 0, 1, 1, 1, 2, so on. Okay. So if you sit writing like this, it is an infinite set which never ends. Infinite set which never ends. Clear? So that's why I am telling both domain domain and range are integer set, as well as range is also integer set. Clear? So quickly give me your thumbs if you have understood this. Please tell me, have you understood this? Okay, so then we can continue the next concepts in the tomorrow's class. So thank you to everyone. Take care, be safe. See you, take care, and let us meet in the tomorrow's session. Let us meet in the tomorrow's session. Till then, take care and see you. Bye.